So before we start section 4.5, let's do a bit of a review on long division, because section 4.5 is about dividing polynomials. So long division is dividing winner typo of the day, two numbers by hand to get a remainder. So for example, 2 does not divide 9 evenly, i.e. you get a whole number, right? There's always a remainder of 1. You divide the dividend, that's what's under this symbol, the dividend, by the divisor to get the quotient, right? The quotient is what we get when we divide, and a remainder. So let's work through some examples of how long division works. I've got 2 examples on this next slide, but we're going to do more. So if I took 19 divided by 3 long division ways, yes, I know we could do this on a calculator, but you can't divide polynomials on a calculator, so we're going to go over long division again. I would take 3 and see, okay, how many times does 3 fit into 1? Well, it doesn't. Okay, how many times does 3 fit into 19? That's going to be 6. 6 times 3 is 18. You subtract this, what you multiply together, in order to get 1. So this is our quotient, and this is our remainder. So this would leave me 6 and 1 over our divisor, third. Or you could write this 6 remainder, or just r 1. Next, let's take 674 divided by 27. I don't like either of these examples. We're going to do some better ones. 674 divided by 27. Well, 27 doesn't fit into 6, but it does fit into 67. How many times does 27 fit in 67? Twice. 2 times 27 is 54. If I take 67 minus 54, that's going to give me 13. So I've got 134. Now I want to know how many times does 27 fit into 134, and I think the answer is 4. So I'm going to try that. I'm going to do 4 times 27. That gives me 108. So I subtract that. That leaves me with 26. So 26 is my remainder, and 24 is my quotient. So notice what I'm doing. Notice this iterative, meaning repeating algorithm that I'm following. I see if 27 fits into a term. I figure out how many times it fits into that number. I multiply. I subtract to get what's left, and I pull down the next term. Let's work through a better big example. Am I going to be brave and start with another one? Yes. Okay. So let's switch to green. What if I took 48 divided by 3? My first step. How many times does 3 fit into 4? That's going to be 1. 1 times 3 is 3. I subtract 3 to get 1, and I pull down the next term. How many times does 3 fit into 18? 6. 6 times 3 is 18. Minus 18 gives me a remainder of 0. That's because 48 is evenly divisible by 3. What if I took 124 divided by 9? And then I'll make up another example bravely off the top of my head. We'll see how that goes. Okay. How many times does 9 go into 1? It doesn't. But how many times does 9 go into 12? Once. 1 times 9 is 9. If I subtract 9 from 12, I get 3. And I pull down my next term, which is 4. How many times does 9 fit into 34? 3 times. 3 times 9 is 27, so I get a remainder of 7. And a quotient of 13. All right, let's try again. Let's do a big one. If I took 8,769 divided by 7. Okay, let's see how this goes. Did I leave myself enough room? Probably not. How many times is, you know what, let me go ahead and rewrite this up here. So I've got more room. I want to make sure this is a good multi-step example. So I did 8,769. 7 goes into 8 one time. 1 times 7 is 7. I subtract 7. 8 from 7 is 1, and I pull down my next term. How many times is 7 going to 17? Twice. 2 times 7 is 14. I subtract that to get 3, and I pull down my next term. So I have 36. How many times is 7 going to 36? So I've got 7, 14, 21, 26, 35. Ooh, that's pretty close. Which is 5. 5 times 7 is 35. Subtract 35 to get a 1, and I pull down my next term, which is 9. 7 times 19. Oh, I should have made that a 4. That would have worked out nicely. 7 goes into 19 twice. 2 times 7 is 14. My remainder is 5. So 7 fits into 8,769, 1,252 times with 5 as the remainder. So that was a little refresher of long division. You're going to use this iterative process to divide polynomials in the next section.